Hello again, this is Professor Evans. This video is for EET 1214C, Intro to Engineering. And in this video, we're going to go over a Multisim tutorial for how to build a series circuit as well as a parallel circuit in Multisim and take some measurements. So as you're watching this video, what I'd like you to do is open up Multisim and follow along with me. So I'm going to add a text block at the top explaining what we're going to do. So we're going to build a series circuit and a series DC circuit and take measurements. When we're done, we'll then build a parallel circuit and do the same thing. So I'm going to make my font a little bit bigger here. And this is our goal for today. All right, so I'm going to begin by building the circuit that is in your lab manual for DC circuit measurements. That's the name of the lab, DC circuit measurements. So if you have your lab manual, go ahead and open up your lab manual and find that circuit that is shown in figure 1. In this case, we have a 15-volt source in series with 2 resistors. So I'm going to start by building that circuit. I'm going to go to Place and Component, and I'm going to start with getting my source. So I'm going to start with a DC power source that I'm going to add to my schematic. And then I'm going to go get 2 resistors. Those are in the basic column. I'm going to go down to resistor. I'm also going to get a ground from the sources column. Now that I have my components, I'm going to rotate R2 so that I can make a nice square shape, just like the manual. The ground is always tricky to connect, so I always connect that last by dragging it up to my wire like that. Now, if we look at the schematic in our lab manual, you'll see that the voltage source should be 15 volts. So I'm going to double click it, go to the Value tab, and change that to 15. R1 should be 330 ohms, so I'm going to set that value. Again, double click that resistor, and if the Value tab does not come up already, just click the Value tab and change its value. R2 should be 680 ohms. Just going to move R2 up a little bit, and there's my circuit. So the first thing that we want to measure in this circuit is the total current in the circuit. So in order to measure current, we have to break the circuit and put the ammeter in series. So I'm going to add a text box over here with a reminder of how we measure current. All right, so here's our little reminder. To measure current, we have to break the circuit and place the ammeter in series with the element you wish to measure current for. So I'm going to go get an ammeter. Go to Place, Component, change the group to Indicators, and here's an ammeter. We have 4 options. Horizontal, notice the positive terminal is on the left, negative is on the right. Horizontal reversed, look at the terminals. Now the plus and negative terminals are just flipped. Vertical, vertical reverse. So you're going to pick the ammeter that corresponds with how current will enter and exit. If current is going to enter on the left, you want the positive side where current will enter and the negative side where current will exit. In this case, I'm going to use an ammeter and I'm going to put it right in front of R1. So the current is going to go in to the left. Right, so here's my ammeter. I'm going to go ahead and remove some of the properties that are displaying with this ammeter because the extra text just takes up space and we don't need it. So I'm going to turn that stuff off like that. And now here's how we break the circuit. When we break the circuit, we literally create an open connection. So I'm going to delete this wire and I'm going to place the ammeter in series with the resistor. Then I'm going to connect the ammeter so that current flows into the positive terminal, out of the negative terminal, and into R1. All of the current has to flow through the ammeter before it flows through R1. That's how we're going to capture our total current in the circuit. Now I can hit play, and I have a measurement, 15 milliamps. That is my total current in the circuit. Now we're going to measure the voltage for R1 and the voltage for R2. To measure voltage, I'll put a note over here. We're going to place a voltmeter in parallel with the element you wish to measure voltage for. All right, so when we measure voltage, we have to now place a voltmeter in parallel with the element we want to measure the voltage for. In that case, I need a voltmeter in parallel with R1 and a voltmeter in parallel with R2. So I'm going to show you what that will look like. First, I'm going to move R1 over just a little bit because I need some space. Next, I'm going to go back to that indicators group, go to voltmeter. I have two options, horizontal and vertical. In this case, I'm going to grab a horizontal one for my horizontal resistor and a vertical one for my vertical resistor. Again, I'm going to go to the display tab and turn off all the values because, as you can see, it clutters the circuit and adds text that we don't really need to see. Now, to connect my voltmeter in parallel, I simply connect each terminal of the voltmeter to either side of the resistor. Again, the positive side is where current would enter the resistor, and the negative side is where current would exit the resistor. So we see those polarities there. And we're going to hit play. And now I have the voltage drop for R1 as well as the voltage drop for R2. I'm going to show you some other ways to measure voltage and current besides using the voltmeter and the ammeter. Another thing we can do is go to place, probe, and get a current probe. A current probe is just like a tool that will take a measurement for you. And you use the probe while the simulation is running. And you can just hover the probe over the particular current you want to measure. And it's got several values. Some of these values we haven't talked about yet, but you can see at the top that the current being measured is 14.9 milliamps. Very, very close to the 15 milliamps being measured with the ammeter right there. So that's how we can use a current probe. We can also get a voltage probe. It's called a differential voltage probe. You place the probe on either side of the resistor, just like with the voltmeter, and you get a measurement, 4.9 volts. That's another way that we can measure voltage using probes. When you're done, you can just delete the probes. Now, in addition to using the voltmeter and the ammeters, there's a third tool we can use to measure current and voltage, and that's a multimeter, which is shown right over here. The multimeter has a symbol that looks like this. So now I'm going to copy and paste this entire circuit, but I'm going to replace the voltmeters and the ammeter with the multimeter. So I'm going to copy, scroll down, paste, and instead of using the ammeter, I'm going to put the multimeter in its place. Instead of using the voltmeter, I will put the multimeter in its place, connected in parallel. And the same thing goes for down here. I'm going to rotate this one and flip it so that the positive terminal is on the top and the negative terminal is on the bottom. Now, when I hit play, I can double click each multimeter, select the value I want to measure. This one is measuring current, so I need to select the amps. There's my multimeter measurement for current. I can double click the next one to get my voltage measurement for the first resistor. Double click the third one, and I have a voltage measurement for the second resistor. So that's a third way that we can use a multisim tool to measure current and voltage. Now I'm going to stop the simulation because I'm done collecting data for right now. So we've discussed how to measure total current and the voltage drop for each resistor. Now let's discuss how we measure the total resistance in the circuit. So I'm going to go ahead and close these. I'm going to add a note up here for measuring total resistance. All right, so here's what we're doing next to measure total resistance. Remove the power supply completely, connect a multimeter in place of the power supply, and set the multimeter to measure ohms. So to measure the total resistance of our circuit, I'm going to delete the power supply completely. I'm going to copy and paste this multimeter since I've already got one here on the screen, and I'm going to replace the power supply with that multimeter. Then I'm going to open up the multimeter and hit play and set it to ohms. And I can see that my total resistance for the circuit is 330 plus 680, which is 1.01 kilo ohms. This is how we measure our total resistance for the circuit. And then lastly, if I was going to measure the resistance of a resistor, we're simply going to take that resistor and connect its terminals to either end of a multimeter. And set the multimeter to measure ohms. When I hit play, I'm going to get the 680 ohms that I set this value to. In Multisim, this might seem a little redundant, but when we build our circuits on the bench, one of the things we're going to do is measure the resistance of each resistor we're using. So this is just a recap and a translation of everything that we do in Multisim. We do the same way on the bench. On the bench, if I was measuring the resistance of a resistor, I would connect either terminal to the multimeter and set it to ohms. So I'm just showing that same step in Multisim as well. So we've built a series circuit in Multisim. We've discussed how to use the ammeter, the voltmeter, and the multimeter to measure current and voltage. And we've also discussed how to use the multimeter to measure the total resistance of the circuit. Let's also take a look at a parallel circuit. So I'm going to go ahead and remove my second circuit down here so that I've got some space. I'm going to copy and paste this first circuit down here, and I'm just going to turn it into a parallel circuit. So first I'm going to remove the ammeters and voltmeters. I'll just put them over on the side for now. Let's turn this into a parallel circuit. So I'm going to rotate R3. I'm going to connect it in parallel now with the source and R4. So I've got R3, R4, and my 15 volt voltage source. Now, when we add an ammeter to the circuit in Multisim, you don't always have to break the circuit by deleting this wire. If I take my ammeter and simply drag it and drop it right where I want to measure the current, notice that the terminals on either end turn a light blue color. If they turn a light blue color, that indicates it's going to connect itself to the circuit for you, and it's going to break the circuit for you. So when I let go, I can see my ammeter is now in series here. And if I tab up or tab down and the wires go with me, I can see that it's been connected properly. So I have an ammeter here to measure the total current in the circuit. I'm going to add my voltmeter here on R4. We know we have a node here, so this total current is going to split and take two paths. One path is through R3, one path is through R4. So I'm going to add another ammeter to measure the current for each path. So there's the current that I'm going to measure here. Notice that I've still got the same measurement from before. I haven't hit play yet, so these have not updated themselves with new data. I'm going to go ahead and get one more ammeter for R3, a vertical one. And I'm going to place it right there so that it's in series with R3. And look what happened. I connected on one side but not the other. That's why when we insert our ammeters, we want to make sure everything is connected before we hit play. And usually if you just tab over, make sure the wires go with you, you can see that it is truly connected. I'm going to go back to that display tab and turn off all these values. And now I'm going to hit play. So I can see the total current in my parallel circuit is 68 milliamps. I can see that 45 milliamps goes through R3, 22 milliamps goes through R4. The voltage for R4 is 15 volts. R3 and R4 are in parallel, and they're in parallel with the source. So I know the voltage for R3 and R4 are going to be 15 volts. And I can see using KCL that the current going in is equal to the sum of the currents going out. In my first circuit, I can see using KVL that if I add the two voltage drops across R1 and R2, it equals the source. So we want to make sure we're always using those tools, Ohm's law, KVL, KCL, to check and verify our work as we're building our circuits in Multisim. And then lastly, if I wanted to get the total resistance of this circuit, this parallel circuit, delete the voltage source, grab a multimeter, and connect it where the power source was. Open it up, click ohms, hit play, and you have your total resistance of that parallel circuit. So now that we've done all of this work in Multisim, we're ready to go and build this series DC circuit on the bench. What you're going to do is learn how to also measure these currents, voltages, and total resistance on the bench, and make sure that you use your Multisim work to compare your values. Make sure that everything that you've done in Multisim matches on the bench. So Multisim allows us to have a first-hand view on what's going to happen when we build our circuit on the bench, and then we can use it as a checking tool so that we can verify that our circuit on the bench is working correctly. So that's it for this video demonstration of building a series DC circuit in Multisim, as well as a parallel DC circuit and taking measurements.